I'm going to talk about products and quotients of radical expressions. Let's start with products. Here is the key formula to focus on. All right. What this says is that if you have a product of radicals and both radicals are of the same type, then they can be combined into a single radical of the same type as shown. All right. So both pieces underneath the radicals, you could multiply those pieces together, and that will be what's underneath the final radical. All right. So let me show you some examples. The square root of 3 times the square root of 7 is equal to the square root of 3 times 7, or 21. The square root of 5 times the square root of 2 is equal to the square root of 5 times 2, or 10. All right? I hope that is clear. Now I'd like you to try to use this formula. Please combine these radicals that are being multiplied together. Okay, pause the video and do that now if you like, please. Okay, I'll go ahead and show you what the answers are. So the first product simplifies to the square root of 3x. The last product, you can do any pair of radicals first and then multiply that answer by the remaining radical. So this one simplifies to the square root of x times y times z. Now, let me remind you that this rule applies to more than just square roots. For example, if we had the 7th root of 3 times the 7th root of 7, we can simplify that product to the 7th root of 3 times 7, or 21. Okay? Let me let you try one more. Would you please simplify this product of radicals? The cube root of a squared times the cube root of b. So pause the video and do that now, please. Okay, so just like in the examples involving square roots, we simply multiply the pieces underneath the radical. So for this, we get the cube root of a squared b. Okay? Now, there is something very handy about having this formula in your back pocket. You can go in the other direction. So far, we've been combining two radicals into one, but sometimes it's handy to turn one radical into a product of radicals. Sometimes that helps us to simplify things. Let me show you an example of that. So suppose you had the square root of 8. You could write that as the square root of 4 times the square root of 2. And that would help you to see that the square root of 8 is equal to 2 root 2. Okay? Here's another example. If you had the square root of 45, you could write that as the square root of 9 times the square root of 5. And that might help you to see that the square root of 45 is equal to 3 times the square root of 5. Okay? So you may want to do that sometimes. So let's have you do an example of using the given formula to simplify a single square root now. Would you please simplify the square root of 50 and the square root of 28x cubed. Pause the video and do that now, please. Alright, so I'll go ahead and do it as well. So the square root of 50 is equal to the square root of 25 times the square root of 2, which gives 5 root 2. The square root of 28x cubed is equal to the square root of 4 times the square root of 7 times the square root of x squared times the square root of x. That simplifies to, let's see, I'll show you how each piece simplifies. The square root of 4 simplifies to 2. The square root of x squared simplifies to x. So we get 2x times the square root of 7x. Okay? Now, let me remind you that you can do the same thing with more than just square roots. Okay? If you had, for example, the cube root of 250, you could write that as the cube root of 125 times the cube root of 2. The cube root of 125 is 5, and so you could simplify the original radical to 5 times the cube root of 2. Okay? Now let me have you try to simplify 2 more single radical expressions that involve other types of roots besides square roots. Would you please try to simplify the 4th root of x to the 7 y to the 4 and the cube root of 54 x cubed y to the 5th power. Okay, so pause the video and do that now, please. Okay, I'll go ahead and do it as well. So I can rewrite this as the 4th root of x to the 4 times the 4th root of x cubed, and also the 4th root of y to the 4. So all of those 3 radicals multiplied together, and the 4th root of x to the 4, that's just x. The 4th root of y to the 4, that's just y. So x times y multiplied by the 4th root of x cubed. xy times the 4th root of x cubed. All right? And then for the last one, the cube root of 27 times the cube root of 2 times the cube root of, let's say, the x cubed that's already something that we can do, so we don't really have to work to modify that. So let me keep that as the cube root of x cubed. But y to the 5th, let's make that the cube root of y cubed times the cube root of y squared. All right, now we can simplify the cube root of 27, that's 3. The cube root of x cubed, that's x. The cube root of y cubed, that's y. So we get 3xy times the cube root of 2y squared. All right? Now let's talk about quotients. The key formula with regards to quotients is the following. So what this formula says is that if you have a radical of a quotient, you can express it as a quotient of radicals. Okay? So let me show you some examples of that. the square root of 16 over 25, that's equal to the square root of 16 divided by the square root of 25, which is equal to 4/5. The square root of 36 divided by the square root of 36 over 49 is equal to the square root of 36 divided by the square root of 49. That's equal to 6/7. All right? So let's have you try to use this formula. Would you please simplify the following radical expressions? The square root of x to the 4 over 64 and the square root of x cubed over y to the 4. So pause the video if you like and try that now, please. Okay, I'll go ahead and do these as well. So I'm going to write each radical as a quotient of radicals. And so then for the first radical, I can simplify it to x squared over 8. For the second problem, I'm going to write it as a quotient of radicals. And I can simplify the numerator and denominator separately now. X root x over y squared. All right? And remember that this formula applies to other roots besides square roots. So for example, the cube root of 27 over 125 is equal to the cube root of 27 divided by the cube root of 125, which gives 3/5. Okay? So let me have you try one involving cube roots now. Would you please simplify the cube root of x to the 5th power over y to the 6th power? Do that now if you can, please. Okay, I'll do it as well now. The cube root of x to the 5th power divided by the cube root of y to the 6th power. So that gives, for the numerator, x times the cube root of x squared. And for the denominator, y squared. All right, and so that is the simplified expression. And I hope that's what you got.